Determine which of the following subsets of vector space R cube are subspace of R cube. Here 5 set of vectors are given and we have to identify which of them is subspace of R cube. In order to solve this problem, first of all we have to know what is a subspace of R cube. A non-empty subset of R cube is a subspace if it is closed under addition and scalar multiplication. Then that is said to be subspace of R cube. If we see S1, we can take example 1 0 0. It belongs to S1. Here a plus b is equal to 1. So here a plus b is 1. So 1 0 0 belongs to S1, and we can take 0 1 0 which also belongs to S1. And if it is subspace, then it should be closed under addition. So let us find addition of these two, 1 0 0 plus 0 1 0, which is nothing but 1 1 0. But it doesn't belong to S1. Why? Because here a plus b is 2, but given a plus b must be equal to 1. So we can say S1 is not a subspace of R cube. So we can eliminate S1. Now let us check with S3. Now let us take example for S3. 1 0 0, it belongs to S3, and 0 1 0, this also belongs to S3. Now let us find addition of these two. So addition of these two will give 1 1 0, and it doesn't belongs to S3. Why? Because it is given that AB should be 0, but here AB is 1. So we can say we can eliminate even S3. Let us take example for S4. Here S4 set of vectors ABCs are such that A is equal to B square. So we can take example as 1 1 0. It belongs to S4. Why? Because here A is equal to B square. If it is subspace of R cube, then it should be closed under scalar multiplication. But if we take 3 into 1 1 0, it is nothing but 3 comma 3 comma 0. Here this doesn't belongs to S4. Why? Because here A is not equal to B square. So we can eliminate even S4. The set of vectors A comma B comma C such that A is equal to B is equal to 0 will satisfy the condition that it is closed under both addition and scalar multiplication. And the same is case with S5 also. Set of vectors A comma B comma C such that A is equal to B. Even this will be closed under addition and scalar multiplication. So we can say both S2 and S5 will form the subspace of R cube. So here correct option is option C.
This question, adjacency graph of an adjacency matrix of an undirected graph is given, and we have to find the number of bridges. Number of bridges is nothing but number of cut edges. A cut edge is an edge deletion upon which disconnects the given graph into two or more components. So in order to solve this problem, we have to first we have to construct the graph by using the given adjacency matrix. So let us try to construct the graph. So here the vertices are P, Q, R, S, T and U. Here there is an the entry 1 indicates that there is an edge between those those respective vertices. Here 1 is present on in row upon column, in row P upon column Q. That means there is an edge between the vertices P and Q. 0 means there is no edge between those particular vertices. Here 1 is present. That means there is an edge between vertices P and Q. So let us draw an edge between P and Q. There is also an edge between vertices P and R. So let us draw edge between P and R. Let us go into row Q. There is an edge between Q and P. There is also an edge between Q and S. So here edge between P and Q is already drawn, and we need to draw edge between Q and S. Now let us go to the row R. There is an edge between P and R, and there is also edge between the nodes between the vertices R and S and R and T. So here P and R is already drawn. Let us draw the edge between R and S and R and T. Now let us go into the row S. We can see there is an edge between S and Q, S and R, which are S and Q and S and R. Here we have already drawn those edges. So now let us go to the row T. There is an edge between R and T and R and U. We have already drawn the edge R and T. Let us draw the edge between the vertices T and U. Now if you see row U, there is only one edge between T and U, which we have already drawn. So the given graph is this one. In this graph, we have to find the number of bridges. Number of bridges is nothing but number of cut edges. Here, the number of here we can say the edge between R and T, that is this edge, is cut edge. Why? Because if we delete this edge, the graph gets disconnected into two components. One is this one and the other is this one. And if we delete the edge between T and U, that is, if we delete this edge, the graph would be disconnected into two components. So we can say there are two cut edges. That is, cut edges are nothing but bridges. So bridges is equal to RT and TU. If we let us see if there are more cut edges. So if we delete the edge between P and R, nothing is going to happen. Why? Because the graph still remains connected even if we delete the edge PR. And the same is the case with edge PR and QR, QS and RS. So there are only two cut edges. So here correct option is option C.